Okay, in this video we're just going to look at resistors in series, so one after the other. So in resistors in series, if we were to apply a potential voltage at either end of the two resistors, then the current can only flow down the wire and then through each of the resistors. It's got nowhere else to go, so we're going to have exactly the same current going through both resistors, so therefore we can actually replace both of those resistors. Our total resistance is just going to add the two resistors together. So we're going to have the same current So as an example there, I've got these two resistors, 5k and a 25k. So my total resistance then is just going to be 5k plus my 25k equals 30 kilo ohms. Nice and easy, nothing to worry about there. I don't think we need too many examples on that. I think you grab that. So if we wanted to work out what the current was flowing in the system, then current is equal to voltage divided by resistance. And now we've said the equivalent resistance for, if we say on this circuit, is 30k. So, and let's say we've got a 9-volt power supply. So therefore then we can work out what the current is going to be. So just writing it all out in full and then using my engineering friend, I got 300 times 10 to the minus 6 units, remember, amps. So then remembering our engineering notation, so 300 microamps. Okay, so that's what's going to be flowing through both of those resistors. So let's take that idea one step further. So we've got a circuit here, 12-volt battery. It's got an internal resistance of 5 ohms, and we connect a 50 ohm load, some sort of device, whatever it might be, some sort of toy lighting thing or whatever it might be. So it's got a resistance of 50 ohms. So what we want to know is when we connect this circuit up, what will our voltmeter read? What will be the voltage across our output device of 50 ohms? So we do exactly the same process as before. We need to know what the total resistance in the circuit is, so we can then work out the current flowing in the circuit. So we've got 55 ohms, so therefore then we can work out the current in the circuit. So current is equal to voltage divided by resistance. So we've got our 12 volts divided by our 55 ohms. Gives me 218.2 milliamps flowing through in that circuit. So that 218 milliamps is going to go through this 5 ohm resistor, through the 50 ohm resistor, and then back round to the 0 volts of the battery. So let's work out what the voltage we've got across our 50 ohm load. Now voltage, the voltage across a component, notice our voltmeters are across that 50 ohm resistor, so the voltage across a component is equal to current times by its resistance. So popping all the numbers in, what do we get? 10.9 volts. Okay. So 12-volt battery delivers 10.9 volts across our output device because I've taken into account the internal resistance of our battery. So, but that's just using resistors in series. Happy days.